We have started last time talking about input and output. So again, so far in NumPy, we were creating our data. So for instance, we would create a range of x values, either using linspace or a range or one of these functions, and then we would do something with it, some known mathematical function, like np, the sin for sine function, and then we would plot that data. Okay? Now, data doesn't always come like that. And in engineering specifically, data comes in as a measurement. Okay? And we need to figure out how to plot that data or look at that data, interpret that data, and what have you. So for that, we have to figure out how to grab the data. There's multiple ways we can grab the data. We can grab the data interactively, right? We can wait for another engineer to type it in. And that's the function input that I exemplified last time. I can say input, and then whatever prompt is here is just really a nicety. It's there for the human reader to figure out what to do. Otherwise, it's just going to show up as empty space, and the human on the other side will be like, well, what do I do now? Right? So we need certain parts in there. So when I type in how old are you, that's pretty much what's going to get printed right here. And however I formatted it, that's what's going to happen. And then whatever I type in is the answer that computer will grab. And then I can do something with it, as long as the computer can grab it. These days, you know that. You're constantly typing in the data into the browser. Okay? You go to look at your credit card or bank statement or what have you, you will be typing in data into forms, right? And on the other hand, somebody is grabbing that information and acting accordingly. We're going to get to acting accordingly part. What do you do with the data later, and how do you direct the flow of what's going to happen? But for now, we're concerned about just the very basic things. How do I get the data? Sometimes when the data is large, we don't want to go through the process of typing it in. It might be a large file of measurements that somebody has saved that I'd like to read it. And that's actually going to be the major task today. And the major part of that is knowing the format of your data. Okay? So I'm going to show you 2 or 3 different ways of how to read and write the data. But I want you to remember that you have to know what the format of that file is. And you have probably already gone through that process already. So for instance, with this IP, Y, and B for the files that your Jupyter notebook is putting out, most of the time, your either browser or computer doesn't know what to do with it, right? So you try to kind of automatically open it, and they're like, well, I don't know, I'm going to download it, right? And then you have to go download it. And you open the software that you know opens those files. Did you see that? So some of these things for simple files like Word documents, Excel sheets, text files, those are photographs. Those are simple files that travel in formats that at this point in time, most of the computers recognize. And when they do, they immediately open. And they might even do that within a web browser. Okay? But for certain specific files and specific formats, and the more complex the data, it's more likely that your regular computer is not going to recognize until you teach it how. So in those instances, you have to just download the data, save it somewhere in a known location. Known location means, a folder that you can navigate to, which can also be quite intricate. You can see how long it took me to navigate to the one that I have created, which is a subfolder of a subfolder of a subfolder of a subfolder. Or maybe, you have probably noticed that too, your data, you decided to put it in the cloud, but then that cloud data is not synced with your computer in a correct way, and navigating to it might not be easy. Okay, so you need to put certain links in place in order to be able to find the data. So if you get confused in the process, you're not alone. Okay? Work through it, ask us for help, So you should know what it is that you're downloading or by looking at it. Then you go to the software that opens it. And that can be your Python notebook. It can be something else. Okay? Works in all cases. If your computer automatically is not programmed to open it, that means that you need to help it out. Okay? So save it where you know where it's at. Go open the software that you know that opens it, and then point that software. Use open command in that software, and then this link will be established. So let's go through a very simple example of this. So first things first, let's figure out what files are. And let me just open the PowerPoint. So I'm going to go back and forth with the PowerPoint as usual. So this is sort of the type up of the long story that I mentioned on 5 file formats. So let's actually go through this exercise of creating a file. Okay? And then we're going to try to read the file right out. So let's just try to read the file. I have certain information in here. If you don't, we can just, does everybody have what we typed in last time? Or I can just say, hey, new text as input, type something in. And when I execute that, I'm going to type something in. Today is partially cloudy, resulting in temperatures below 95, which we call fall or cold around here. So now I can print that text. So this is the first check that computer has recognized what I put in. If I do a type of this new text, it's a string, so it's just a text. Okay. Now, printing to me doesn't save this text. Okay. It prints temporarily here on the screen, but I cannot share it. I cannot email it. Okay. I cannot post it to some folder where somebody else can read it. So let's now actually just open a simple file and store this information in. The very simple way of procedure that we need to employ is open the file under a certain name. This means that I will be able to find the file later under that name. If I don't tell it otherwise, it's going to place the file in the folder I'm in. So hopefully you know which folder is your Jupyter notebook pointing to. If you don't, then you can kind of look it up. If you try to open something, right, you will actually get the folder that you're in. For me, it's this pretty long sequence, okay? So that's where the file is going to be in. Now, after that, I will write the information. And when I'm done writing, I need to close the file. All of these are important. Opening file under a certain name enables me to actually find the file later. And enables the computer to actually name an address, figure out where to put the information, name an address so that we can do that later. So there's certain procedures that have to happen here. Then I type in the information that I put in, which has to be in the format that I know that somebody else will be able to read later. And then finally closing the file literally locks the door. It doesn't leave the door open, locks the door so the data doesn't get overwritten by some new writing of the file or whatever it is the computer may do. Literally, my dog will run outside if I don't close the door. I gotta close the door to keep my dog inside. Pretty much, if I don't want to lose the data, I should keep the door closed. I should close the file. Now, some of them, in a very basic sequence that I'm going to show you now, I want to show you this process. And sometimes my dog will find her food bowl full, so she will not run outside. I'm not going to always lose the dog if I keep the door open, but most of the time I will. Okay? So, confusing part of it is if you don't close the file, sometimes everything will be just fine, and sometimes you will have a corruption in the data because some other process came in and has overwritten your data. Okay, the data is gone. So in that sense, the process of opening, writing, and closing is pretty important. So let's actually do that process. So basic procedure is open. And basically you want to open a file under a certain name and in certain mode. And with modes we mean writing, reading, and appending the data. Appending is addition, okay? Then after that we will use the function write, and within the brackets is going to be what we want to write into the file. And then after that we're going to close. And there are different types of writing to file that depend on the type of the data that I want to write to the file. So I might want to write text as something that is readable as text, or I might just store the numerical data. Okay. And for numerical data, as usual, we're going to refer to our friend NumPy, okay, which is the module that has everything. And then I need to close. So this is going to be a very basic setup of reading and writing. So let's do that. And I'm just going to literally use this text here, new text, and I'm going to write it down. So I'm going to say, hey, my file, this is name of the object in your programming that is going to refer to that file. So whenever you want to modify something in the file, you're going to use my file or whatever other name you give it. So I'm going to say open, and I'm going to say simple text file, and I'm going to give it a hint that this is going to be a text file. A common ending for that is txt. Most often than not, when you say txt, a lot of editors, web browsers will know how to read that file because they're programmed to do so. If you give it a different ending, they might get confused. You can still go and open them with those same pieces of software, knowing that you're opening a text file, but they might get confused in trying to do so automatically. So this ending is an important hint in recognition of what comes in. And I'm going to say open the file for writing. And then after that, I'm going to write something into it. And this write command pretty much functions like print command. But since I'm saying my file write, it basically, whatever would normally show up on the screen will be printed into that file. That's essentially how you do it. So anything that you can do with print command, you can do with this write command. It's just going to go to the file and not to your screen. Okay? So let's gonna just, that text variable, you can just write inside. And then my file, close. And this is that closing of the file. So open, write, close. What happened? No errors happened. It's not yelling at me. Printing some weird errors. That's good. But how do I check? It didn't print anything to the screen because I didn't ask it to print anything to the screen. So how can I check whether this file exists? So I need to look into this folder and see whether there's a file open with this name. I gave it a name, simple underscore text underscore file.txt. Here we go. A minute ago. Must be it. So you can order by the when was modified. And you can also go and open this from, and if I open it, So my web browser recognizes that txt is a text, and it knows how to open text. It says today is partially cloudy. It has one line in there. That's it. I could have continued. Let's close this now. And let's just print something else. And there are certain special characters that will add a new line, otherwise it doesn't know how to go to new line. This is a character for a new line. And in new line, I'm going to add, well, it's going to be sunny later today, and then our 100-degree temperatures will return. Up. So this tells computer, oh, jump to a new line, otherwise you can't just place enter. Enter we use for all kinds of, or return on your keyboard, you use for all kinds of other things. So this is basically a code for a special character. Go to new line. So now if this executed, I should see things change. Seconds ago, indeed, I changed this file. And I have 2 lines now in there. Yes? Okay. Now let's assume, so this is just a simple way, we could now play with this and write whatever it is that we want to write into this text file. And that's going to be information we can read. Now point your browser, so there should be, on your canvas, if you go on canvas, there should be a file temperature.txt. Can you please check that that's indeed the case? Temperature.txt. And I'm going to open it first to look at it. So this file has the following information. So somebody has recorded some data. Title of it points that that data should be temperature. If that title was something else, I wouldn't know. So think about that when you are saving the data. Give meaningful names to files. And then first line has some text. Month, high, low, average. So apparently I have month temperature for month, and then I have a high, low, and average. This is now logic. Obviously, these should be 12 months. High temperature going between 45 and 81. Is this Texas? No. Michigan or something. Okay? And then low from 33, not Michigan. Michigan is colder than 33. Okay. Upstate New York. Okay. So low is in 33 and 56. Isn't that nice to have August a low of 56? Beautiful. Chilly, actually, too cold for me. And then average. Okay. So what I'm actually pointing right now is actually using your common sense to interpret what's in the file. Never forget your common sense. Okay. So just to check whether data seems to be okay, And what is in there really? Are the numerical values that I see in some sort of expected range? Now we have a task of reading this file. First thing, you need to go to Canvas, download it somewhere where you know, and hopefully you download it into your PGE310 folder, whatever subfolder you have in there for stuff that is done in lectures. So please do so. And hopefully place it in the same folder as this exercise that you're typing in right now. So we're gonna call this now temperature file. You can call it my file again, but that will overwrite whatever we called my file earlier. So you are free to use the same names for things, but the moment you use them in a different context, the old information will get overwritten. And most of the time, it's not going to ask you, are you sure you want to overwrite? It's just going to overwrite. Okay? So my temperature file, I'll say, hey, open, and open this temperature. You need to give it a name. If it was in different folder, I would have to now line up all of the folders and how to get to it, okay? But I'm using the fact that my file that I'm reading and my Jupyter notebook are in the same folder. Otherwise, I have to have here all of the other folders the way they, all of these, okay? So for the full absolute address on my computer. I don't want to type. I'm a lazy typist. Okay? So I'm not going to do that. That's why I'm placing them in the same folder. But there's no problem opening a file in a different folder. You just have to give it precise. And this file we're going to open for reading. So this is a reading mode. And this is good because it's going to prevent us from adding anything to that file right now and corrupting the data that is in there. All right. So when you just place Shift Return or Shift Enter, depending on which computer you're on, if nothing happens, that's good because there's no errors. That means that it found the file, it managed to locate the file and get it at its beginning. Okay, so I'm going to continue here. And I'm going to first do there's a command that just reads the first line in a text file. And this is a text file. The first information, what I really want to do is get to this data and plot it. Okay? Now, first line just tells a human reader, hey, this is monthly temperature per month, and then there's high, low, and average. So I don't need that line. I can just do this and read it. If I want to store it, I'm just going to say, hey, first line. So this will basically store that first line, but I don't really need it, so I don't even need to store it. But I do need to read through it because files are sequential, so I gotta somehow skip that first line, okay, and get to the data. Great. After that, if I continued using readline or anything that reads text, I would have to read line by line and then recognize numbers in that line, grab them somehow, okay? That's called parsing the text. Grab them somehow, and then basically interpret them as numbers. There's a process there. There's quite a number of, if I know that numbers are coming, there's quite a number of commands that will just go in there and do that for me. They will take all of the data, figure out where the numbers are, and take them out. And that's what we're going to use. Okay? But just know that if you were a computer scientist programming that, whatever comes in with input command or otherwise, it's text, and it needs to be somehow parsed into whatever pieces of information that is in there that you actually need. And for that, you need to know what is the person typing in. So think next time you're typing in something into your search engine. Those search engines are optimized to recognize. Sometimes you totally mistype the address and it still finds something similar because A, it knows it's expecting similar text. B, it kind of uses the information of all of the people that have typed in something similar. And it compares quickly on the fly to what that could be. And these days it also gives you options of what that could be based on what other people have typed in. Okay? But there's something grabbing that text, just like an input command, and parsing it through, analyzing it, and sometimes offering you options of what would you do with that. And if you're on a shopping website, they're like, well, other people have also searched for this and that, and then it gives you option to shop for more. Yes? So again, it's all about parsing what person has inputted. We know, we looked at the file, we know numbers are coming. So we're gonna import our good friend NumPy. And NumPy allows, I'm gonna grab the data that I parsed through. It has command from file. The moment it's from file, I have to give it this file object first. And then I have to tell it a little something about the data that is coming. Data type is float. Remember that real numbers are called floats on computer. Count is, how many do I have? How many numbers do I have? 12 times 4 is 48. Good news is I can actually do that just as a mind check, or I can type in 48. And their separator. Separator is, they're separated by space. In parsing these files, what is a separator is kind of important. Sometimes it's tab, sometimes it's space, sometimes it's comma. Okay? Because it has to kind of know about it to ignore it. And know that once you see a separator, oh, this thing and before it and after it is two different objects now, right? Two different numbers to interpret. That should hopefully do it. And then I'm just going to say temp file close. Didn't complain. So it could complain on finding the file. Second place where it could complain is that you're reading something that is not there. If you try to read much more data than there is, it's going to try to get out of the file, and that's a problem. Okay? So let's just quickly print the data. Okay. I see numeric variables, and they make sense. Type data, it's an array. And shape is, it's a 1D array with 48 numbers. So it did read 48 numbers. So this is now data inspection, right? If you were plotting temperature for every month, how would you like to plot that? How would you like a graph to look like? Month, temperature versus month, right? How do we do that? It seems that it had placed 1, then 45, then 33, then 39. So this is my month, high, low, average. Then again, month, high, low, average. Then month, high, low, average. It's kind of... So how do I modify this so that I grab just month data, just high data, just average data? This is now an array, 1D array. Reshape, thank you. All right, so how would you reshape this? Data.shape. 4 by 12? Let's try.
Never mind. Wait, so when you do data shape, it reshapes it, you only have to print data?
Sure.
You don't have to print data.
Well, I assigned data shape to be 4 by 12, but I don't think that did what I wanted to. That gave me 4 by 12. How about 12 by 4? Let's try in place. If not, we will have to reread the data. Oh, okay. So what did we say about reshape command? Or this reshaping array with shape?
It's hard when it's a one.
It goes through a row, it prints everything row-wise, right? And it just fills in. So if I tell it 4 by 12, okay, that means that I will have 4 rows and 12 elements in the column. So to first fill in the first row, it's going to just take first 12 values it sees in that one big 1D array. Okay? But that's not what I wanted. I wanted to take first 4, and then second 4, and third 4, right? So first thing is to look at the data and see what you want. You can do everything you want. You have to know what you want. It goes for life too. Okay? So question is, when I look at the data, how do I reshape it so that I get this, right? And I need 12 by 4. Okay? And when the data is not presented like a table like this, you have to figure that out. Okay? So on your test, you'll have to figure that out. You can learn the mechanics of how it's done and the commands that it's done with, but you will have to figure out based on what you see. Okay? And it could be different. And you have to kind of know, what's in the array. Okay? Excellent. So let's now actually finally, how can I actually plot my high temperature versus low temperature? What do I need? So how do I grab from this data the first column? Yeah? Everyone in the first column. Everyone in the second, and I gotta start from 0. Uh-oh. Of course. Got lazy typing. And this is that Jupyter business. Sometimes I just have to execute things twice. I don't know whether you see things on your computer like that. But the moment it actually has an out here, That means that it actually knows about the plot. Okay. And then if you want to change something about the plot, red diamonds. Here we go. Yes? After this is easy. You just need to know how to grab the data you need from whatever it is that you're presented with. How would I now save this data into a file? What are the procedures that we need to take when we are writing a file? Open the file, some new file. You gotta figure out the name and where you want to put it. If you don't say anything but just the name, it's gonna show up in the folder where you're at. Then write something into that file. And whether you're writing text versus numerical data can differ. Okay. And then close the file. Yes? Now, did everybody, before I move on, did everybody get through this? Let me just wait a moment for those of you who have, please, I want you to produce this plot, and that's gonna be an assignment quiz for today. So I have plotted this top line, or top data. This is high data. I want the other two as well on the same plot with these type of markers. So average is a cross, green cross and blue circle. I want an annotated graph. This is data obviously in Fahrenheit. I don't think that there is a place on Earth with 80 degrees Celsius just yet. Okay. And month. Okay. So I want a plot like this. So you will upload your notebook, or I think Ningyu prefers a PDF or some sort of a screenshot of both your code and your text. Okay. But for those of you who haven't gotten that, let's make sure that you have the data grabbed in correctly. Has everybody gotten through this without complaints from your browsers? You need help? What is not running? Define not running. All of you stop. Yeah. So this means that it's space. So is this how you
That's it. You didn't do that. Okay. So everybody's still working out? You can work on the rest of this plot. So I could now do a new file or new temperature file. And I'm going to call it temperature
new. And what am I gonna, if I want to write the data, what am I gonna put in there? Which mode? Writing mode? Append is if I would append existing file, so it has to exist. Okay? And then I'm gonna say new temperature file, write. And I can write that same month, high, low, average. NumPy is equipped with also writing the file. The way it reads things from file, it can also write to file. I'm writing to this new file. Separate my data points with a space. And I'm going to give it format. This is a string, so-called string format. So it's going to convert the data that goes into as text because we want to read it as text. Let me execute it. Didn't complain, but I can only really check here to see that the file was open. So again, this is that first line. And this is my numerical data that is going to be placed as a text into a text file and separated by spaces. You could put commas, you could put tabs. So I haven't given it any new lines or anything, okay, in this. So it's actually interesting. Just give me 1 second to open the file to see what happened here. How did it actually output this data? So I didn't give it any new lines, and it did precisely as told. Okay, for better or worse. So I would have to go line by line and put those new lines everywhere. We don't know for loops yet, so we're not going to do it today. Okay? But again, it's always doing precisely as told.